audience members the highest level of respect in refraining from any noise making and/or disturbances while our participants are speaking. And likewise, during the open forum conclusion, that you stay on topic, only posing questions related to the theme. We are truly fortunate to have such high caliber speakers with us here tonight. Dr. Clifford Mass is Professor of Atmospheric Sciences at the University of Washington, holder of a physics degree from Cornell and a PhD from the University of Washington. He worked with Carl Sagan on a model of the Martian atmosphere, and with climatologist Steve Schneider studying the impacts of increasing CO2 levels. A specialist in weather, climate prediction, and simulation, he is currently engaged with an NSF-sponsored project on regional climate modeling. He is the author of more than 170 refereed articles on various climate topics and of the book, The Weather of the Pacific Northwest. Dr. Vincent Miller is the Gudorf Chair in Catholic Theology and Culture at the University of Dayton. He holds a PhD in Systematic and Philosophical Theology from the University of Notre Dame. Previously an Associate Professor of Theology at Georgetown University, he is the author of Consuming Religion, Christian Faith and Practice in a Consumer Culture, and editor of The Theological and Ecological Vision of Laudato Si, Everything is Connected. His current book project is an investigation into the topic of hope in the Anthropocene. We are all here for a special evening, and I thank you indeed for being here. For being here to listen to something I believe is sorely missing in our contemporary society, honest and open debate. That while we, all of us, may come to this room with differing opinions on the subject at hand, certainly share an equal interest in rigorous intellectual exchange. Being many of us professed followers of the one who is the way, the truth, and the life, find our appetites ever whetted for discovering the truth behind all things. Before we begin, I'd like to, at this moment, welcome the pastor of St. Augustine's, Father Chase Haselmeier, to share a few words.
Just very briefly before we begin our official debate, on behalf of Paul Sancherico, our president of the Vandal Catholic Club, and myself, Father Chase Hasno, pastor of St. Augustine's, it's a great honor to be here this evening with you, to have this a great example of healthy dialogue where we take important topics and show respectful debate. I got a chance to have dinner with both of the debaters beforehand, and I know tonight's going to be very lively, interesting, and yet still respectful and important for us to give our attention to. So again, welcome, and let the debate begin.
Our first section is entitled Opening Statement. It is a 20-minute section where each speaker will speak for 10 minutes, uninterrupted, defining or including in his address 7 points. 1, defining the term climate change. 2, addressing where he believes it fits in the, quote, Judeo-Christian tradition. 3, is climate change primarily human caused, natural, or some combination of both? 4, giving a brief history of climate change as they see it, leading into E, 5th point, clearly defining their main argument, their main point they want to bring to this debate. 6, they will tell us is climate change an existential crisis? And finally, final point, what can or should be done about this? Dr. Miller, please.
Thank you, Gretchen, and Father Chase for the invitation. It's an honor to be here with you tonight with Dr. Maas to speak with you about so pressing an issue, one that's affecting us deeply now and cuts to the heart of who we are and how we understand ourselves. Our topic is climate change. I'm not trained in this, but in its broadest sense, I'm asked to define it. Climate change is a change in global or regional temperature and precipitation patterns that have profound consequences for plant-animal communities, including human beings. The global climate has changed many times in the billions of years the Earth has existed. These changes have, with some important exceptions, been slow. Between relatively steady states in which ecological communities could evolve and flourish. During periods of change, biological communities face upheaval, sometimes so profound that we call them mass extinction events. Our concern tonight is human-caused climate change. This has been discussed by scientists since the early 1800s. In 1896, the Swedish chemist Svante Arrhenius calculated that human emissions from burning carbon fuels were sufficient to raise the Earth's temperature. He did this with pencil and paper and infrared photographs of the moon to get some information about how much infrared light was being reflected. It's amazing to do that with those tools. And his projections held up relatively well for the next 100 and so years. Carbon dioxide and other greenhouse gases serve as the Earth's thermostat. Without them, the Earth's average temperature would be near 0 degrees Fahrenheit. There would be no liquid water and light and no life as we know it. A relatively small amount of carbon dioxide, 0.028%, 280 parts per million, and other gases and water vapor are enough to heat it to the average of 59 degrees Fahrenheit, which supports the living world of which we are a part. Small amounts make an enormous difference. Humans have increased CO2 levels by 50% to 420 parts per million, 0.042%, and methane has been raised by another 150% in that period of time. This has warmed the Earth by nearly 2 degrees Fahrenheit. Note that in the past 12,000 years that civilization has existed, the average temperature hasn't varied by more than half that amount. We have already warmed the world beyond any level experienced in the history of civilization. The history of climate change. This has been going on since humans began to cut down the trees and engage in agriculture, plow up fields and plant things instead of the grasslands that are there. But it really took off with the Industrial Revolution, with the burning of coal. It accelerated profoundly in the post-war period with what's called the Great Acceleration, the spread of modern technology around the world based on petroleum and coal, and has accelerated once again with the period of globalization that began in the 80s. Most of the world's greenhouse gas emissions have happened in your lifetime, students here. My response to this challenge is as a Catholic theologian. I can't speak for the Judeo-Christian tradition. I can only speak as a Catholic, but my response is rooted in the book of Genesis in the Hebrew Scriptures. The fundamental sin in Genesis is often described as pride, which is true enough, but that too easily gets lifted out of the biblical story. Humans refused to be creatures and wanted to be as gods. Genesis presents a fuller story of the community of God's creation prior to the fall. It appears with the account of creation in 7 days in the first chapter of Genesis. This places human creation on the 6th day. This is often read as a sign of human superiority, but a close reading shows more nuance. On the 6th day, the familiar refrain, "and God saw that it was good," changes. On that day, God looks not simply at humans, the work of that day, but all that God had created, and finds it not just good, but very good. The good of the whole exceeds any part, including us. Humans are made in God's image in this account and given what is called dominion. The Hebrew word here is radah, military rule. But all of this speaks not of capricious freedom to do what we will, but of being God's representatives and honoring and protecting the order of God's creation. The Hebrew law is full of limits. Limits on hunting animal mothers and their children together. Limits on taking birds with their eggs. On cultivating and harvesting entire fields. And very demanding requirements for Sabbath and Jubilee years when fields must be allowed to lay fallow. Rest, limit is fundamental to this Hebrew vision of what the human person is in creation. God's judgment on Adam and Eve at their expulsion, "Cursed is the soil because of you," describes powerfully the world we have made. We are finite creatures with limited perception and knowledge of the impact we have on the world. We are also sinful, inclined to take without concern, misunderstanding ourselves as separate, and thus always in danger of destroying ourselves along with the living world of which we are part. Refusing to see ourselves as finite, as creatures, we imagine ourselves like unto gods. Is climate change an existential threat? Yes. At minimum, it will severely disrupt civilization. It quite likely could end civilization. And it quite possibly could lead to a new extinction event that involves us. Let's return to the climactic record of relative stability for 12,000 years. Even those small temperature shifts were devastating. Several cold periods in Europe after the Middle Ages, sometimes called collectively the Little Ice Age, caused famine, rendered hungry populations susceptible to plague, and preceded many of the darkest periods of religious and political turmoil and war in European history. Climate change disrupts human civilization. Similar events are taking place now, with similar impact. In 2010, a drought in Russia led it to cease exporting wheat. Global prices spiked immediately, and food riots broke out in poor countries around the world. These riots grew into what became known as the Arab Spring. At the time, Syria was in the midst of its own most severe drought in modern history that had been going on for 3 years. The resulting civil war and slaughter of civilians caused 1 million people to flee, seeking safety in Europe, where their presence contributed to the rise of far-right parties, many of which have subsequently taken power for the first time since World War II. Climate changes everything. In the past year, there have been wheat crop failures around the world. The 2021 U.S. harvest was the lowest. Wheat harvest was the lowest since 2002, as persistent droughts reduced yields. This was followed by a crop failure in the Punjab in India, the breadbasket of India, this spring as temperatures spiked above 110 degrees in the final month as the wheat was putting on its final growth, a key time for the harvest. Then summer crop failures across Europe. A nearly 2-month-long extreme heat wave that hit major Chinese agricultural areas with temperatures above 110, 115 degrees. Warming of the Indian Ocean brought about extreme monsoons that devastated Pakistan, rendering 33 million people homeless and destroying 70% of that nation's agricultural crops this year. These are not simply local fluke events. They form a broad, destructive pattern across the world. Increased temperatures, disruption of historical patterns of snowpack and rainfall bring both drought and extreme rainfall. Although agriculture is the most fundamental loss we face, there are countless other unanticipated effects. The current drought in the U.S. has so lowered the flow in the Mississippi that navigation is closed in some areas. We've seen mind-boggling images of people walking on dunes that were once sandbars. The drought impacts power, not just obvious hydroelectric dams, but coal, nuclear, and older gas plants as well. When the water runs low, we're reminded that these are all steam plants that consume enormous amounts of water to turn their generators. France had to shut down 2 nuclear reactors this summer in the middle of a heat wave because river levels had dropped too low. The coal plants that power the American West draw 156 million gallons a day as states increasingly scramble over water rights. These are just current impacts, which have arisen quickly. We have already doubled the change in the climate that civilization has previously experienced, and we hope to do no more than triple that. But without major, sustained changes to our energy systems, we are on track to multiply that 7 times, raising average temperatures by 3.5 degrees Celsius, 6.5 degrees Fahrenheit, perhaps a degree less, within the lifetimes of children being born today. That's by the end of this century. Civilization is unlikely to survive the high end of that level of disruption. What to do? The answer is clear. Treat this as a civilizational emergency and convert our energy system from carbon fuels to solar, wind, and other sustainable technologies. But we also need a conversion ourselves. We need to face our prideful denial that we are part of a community of God's creation, not gods ourselves. We need to cultivate our ways of perceiving and thinking to attend to the natural connections upon which our lives and all our fellow human beings depend.
How do I get control here? Computer? This one? Does stuff in time till I get up here.
But first I want to thank the Augustine Center. It was very kind to be invited here.
here today to talk about this topic. And so I will start my presentation. Well, I'd like to start with an important message here, and I'll use Mark Twain. He knew everything. It ain't what you don't know that gets you into trouble, it's what you know for sure that ain't so. And what I'm going to tell you is much of what you think is true, much of what you've read in the media or heard from certain politicians about climate change is simply not true. Well, first about this term climate change. Well, the usage has changed. I've been in this business long enough to know it's changed. Climate has always meant the long-term average conditions of the weather. That's what climate means. And generally we talk about averaging over like 30 years or something like that. Now, before about 10 years ago, climate change referred to the long-term evolution of climate from both natural processes and by human intervention. Okay, that's what climate change was. It was everything. But it's changed. Climate change has changed. Recently, climate change has taken on the term of meaning that it's only referring to human caused or anthropogenic climate change, anthropogenic human caused. So today, climate change is interchangeable with anthropogenic global warming. In fact, you go to Google Trends, you go back earlier, I plotted it there. Go back more than 10 years ago, people talk about greenhouse warming. Now they talk about climate change, and they're talking about human-forced climate change. Now, I'm going to use the rigorous definition here. Climate change is forced by both natural and human-controlled processes. And what causes the changes in the climate? First, there's things like internal variability. The climate would change even if human beings weren't here. Interactions between the atmosphere, ocean, land system. I do research in this, I know about this. Changes in solar radiation, that can change climate. Human-forced changes, like greenhouse gas changes or aerosols, smoke in the atmosphere, that can change climate. Volcanic eruptions can change climate. Changes in the land surface, like urban heat islands, that can change climate. And just to so you know that human beings are not the only thing going on here, this is one of the longest temperature records we have from central England, going back to the 1600s. And you see it goes up and down, there's all kinds of variability. And before roughly 1970, that was all natural. After 1970, our global warming from greenhouse gases could have contributed to that warming at the end. Or if you go even back, just to show you that climate can happen naturally, this is going back 450,000 years, and you see ice ages come and go, climate changing. This is natural. Now, the question that will be asked, we will be talking about in this exercise, are humans warming the planet? Well, the answer is yes, we are warming the planet. And one of the main reasons we're warming the planet is due to increases in greenhouse gases, measured if you go to Mauna Loa Observatory. This is a plot from 1960 to now. It's going up. And folks, we are the main cause of this increase in greenhouse gases. As Dr. Miller mentioned before, we've understood the physics of greenhouse warming for a long time and the effects of carbon dioxide. And you add more carbon dioxide and you warm the atmosphere. Now, the effects of human beings putting greenhouse gas into the atmosphere have only been significant since around 1970. And if you look at the plot of the temperatures worldwide, this is from 1902 to 2021, you see warming during the last 30, 40 years. And we're talking about 1 to 2 degrees Fahrenheit. And folks, we're probably behind much of that, okay? Not all of it, but much of that. Now, the best science from people in my field, from the IPCC, an international group of scientists, the best sciences suggests that if we keep on adding CO2 to the atmosphere the way we've been doing, and we start getting better, middle, late century by using more renewables, etc., it is probable that the temperatures of the planet will warm by 2 to 3 degrees centigrade by the end of the century. That's what is kind of the consensus. Right now, we've warmed up about 1.2 degrees centigrade. So we're about halfway there to what we will do by the end of the century if we keep on going on a path that that is kind of probable. Now, there's a big question about this existential threat. Well, let me make everybody comfortable right now. Global warming, climate change, is not an existential threat to humanity. It is not even close to being an existential threat. And this is just not me saying it. Let me see what time it is. The International Panel on Climate Change, an international consensus group of the top scientists, suggests that the global wealth of the world will be about 2.4% less because of global warming than it would have been in 2100. So basically, we're going to get richer and richer and richer by the end of the century, and we're going to be 2.4% less rich. The fourth US National Assessment came to the conclusion that we'll lose maybe 1% of our economic output from a much higher level by the end of the century. Now, there have been a lot of claims that global warming is causing droughts and extreme weather and things like that. Well, this is not founded in reality. For instance, there's been a lot of talk that hurricanes are going to increase from global warming, or have increased. But if you look at the actual trends of landfalling hurricanes here in the United States, there's no upward trend. If you look at the extreme weather deaths and damage worldwide as a percentage of the global, domestic global product, it's actually going down. Okay, I've been asked to talk about the religious aspects over here. Let's do that in the last 3 minutes. Well, I'm going to maybe shock you and say that biblical passages do not stress environmental issues. God gave us dominion over the environment. God told us to subdue the environment. This is in Genesis. Major storms and catastrophic climate events in the Bible, well, this is controlled by God or Jesus or whatever, Moses. But talking to God, and often these catastrophic events were punishment for our sins. And of course, during the Great Flood, God was willing to destroy the entire Earth's ecosystem. So, I don't think you can look in the Bible for too much support on the environmental side. But recently, both Christianity and Judaism have extended their religious precepts to environmentalism. Pope Francis had made a statement, and on the Jewish side, there's concepts of tikkun olam, about renewing and repairing the world. This will be more controversial here, perhaps, this statement, but in fact, all this, the extreme environmentalism we've seen, is creating a new earth religion. This is a new competition for the Judeo-Christian tradition, but borrows from the Judeo-Christian tradition. The new earth religion talks about an apocalyptic future if we don't follow the right path. There's a priesthood. This is activists, climate scientists, and those who do not believe in this extreme environmentalism, the end of the world stuff, are called deniers. No other place in science do you call somebody who disagrees with you a denier. No, only here. There's a female virgin saint who gets revelations, there's Greta Thunberg, and there's reliance on authority. 97% of scientists believe in climate change. Even the term, do you believe in climate change? We never use the word believe anywhere else. So what should be done? The world needs to take a deliberate, rational path forward. We are not faced by existential threat. Global warming is a modest technological problem that will be solved with technological innovation, not by reorganizing society or panicking the population. We need to use nuclear power, both fission and in the future fusion. We need to use renewables, but we need adaptation, managing our forests better, getting more reservoirs in dry areas, using air conditioning when we need it in hot places, dealing with coastal flooding. And ultimately, we will have the technology to pull CO2 out of the atmosphere. So the bottom line, and I've got 21 seconds left, climate change, global warming, is a manageable problem. It is not an existential threat. And there has been a huge amount of misinformation in the press and by politicians that is unconscionable. And I'll just give you one example to end. The Seattle's Mayor Nichols did an op-ed 20 years ago, not quite 20 years ago, saying the snowpack has declined by 50% and will by 2020, there'll be hardly any snowpack left in the Cascades. Well, folks, it's still there. So I'll stop right there. Thank you very much.
We move to our second section, entitled Uninterrupted Questions with Rebuttal. It is a 30-minute section broken apart with 3 10-minute subsections. Each section has a guiding question that will be engaged with under the larger umbrella of climate change. In each section, there are 4 parts. The first question, Dr. Mass will speak for 3 minutes and be rebutted by Dr. Miller for 2 minutes. Dr. Miller will then speak for 3 minutes, be rebutted by Dr. Mass. And we'll follow that format through these 3 questions. You'll see me come to the podium after each 10 minutes. The first question, the topic is science. Science. This question will ask the participants to explain how their position on this issue is supported by various scientific principles they wish to discuss, expound upon, and marshal in support of their argument. Dr. Mass will speak first.
Could you give my presentation back?
Yes.
Thank you.
Sorry. Here's the presentation. Shouldn't that be in the bottom here?
It's actually at the top.
It's at the top, where is it?
You're almost there, from current slide.
Start slideshow?
No.
From the beginning?
Current slide.
This one?
How many people does it take to use PowerPoint?
Okay, too many. Okay, you want to talk about science? Let's talk. I'm a scientist, so let's talk about it. The best science, and I'm involved in this. I run computer forecasts, computer climate models. I do this personally. The best science suggests modest warming. The best science has been poorly communicated by media and politicians, which have hyped and exaggerated the impacts. Now, let me make clear, there is uncertainty in these projections, and there are major weaknesses in some of our models. But the best models we have suggest the warming will be modest, and it does not appear to be any tipping point. That's something that you keep on hearing, that if we warm up, there's going to be this tipping point, we go over the edge, and the world ends. Well, the climate models do not suggest this. I look at the climate models personally. I believe science can develop the energy technologies that can reduce or mitigate the problem. And one thing a lot of people don't think about, one technology we have for really mitigating any effects of extreme weather that might increase into global warming is better weather prediction. Better weather prediction can tell us what extremes will happen. I'll give you an example. Last summer we had a heat wave, right? 10 days before that heat wave, we predicted that it would happen with the magnitude it would happen. We have the ability to predict days ahead that we did not have decades ago. And one thing I want you to think about, you can be sure that there will be major scientific and technical advances in energy production and use that we have not thought of, okay? In 1960, no one could have imagined the smartphone or the laptop. Well, folks, could you imagine the energy technologies that will exist in 30 or 40 years that we haven't even imagined today? There's no doubt about it. And we have that time, because the world is not going to end tomorrow because of global warming. And I'll stop right there.
Thank you. I suppose my first question to Dr. Moss is, you cite the IPCC and actually show the chart of future predictions. The IPCC does not think that 3.5 degrees Celsius is moderate and manageable. In 2019, they released a report that said going beyond 1.5 would bring catastrophic damage around the world. Now, let me clarify what catastrophic damage means. The long tail possibility is extinction. That's not going to happen in your lifetime. It could happen in a few lifetimes, though. Civilizational disruption is happening right now. Catastrophic damage involves people in poor countries with very few resources suddenly facing fundamental changes in their living conditions, where droughts come in and change the nature of agriculture, make it impossible to continue in subsistence agriculture. When ocean temperatures change the nature of fisheries and cause a collapse in their sources of protein. When precipitation patterns change, causing drought for agriculture and also causing forest fires, right? These things are profound, and the IPCC was very clear that 1.5 is the highest we dare go. So I don't know of the consensus in climate scientists that 3.5 is even remotely safe. I'll say more about tipping points in a bit. I'd like to end with the 2 points about better weather prediction. We're not talking about weather, we're talking about climate. It's not about what the storm does tomorrow. It's about how much water comes into this biome over the next 5 years. Or to go on the other side of the Cascades, how much water comes into that biome in the course of a summer. It relies upon a certain end to the dry period for catastrophic forest fires not to happen. Historically, they have happened there. But even a delay of the rain by 30 days suddenly pushes the dry forest into a period where there's a lot more potential for fire. Right? So these things change. These are not just about one storm. It's about large patterns that change the underlying basis of how ecosystems and human communities work. I question the trust in technology that Dr. Moss offered at the end. Our technology will continue to develop, but our technology has developed in a way that's fundamentally Promethean, that views the rest of the world as an object that we can manipulate for our own good. And one of the challenges that I see as a theologian, you cited Pope Francis's Laudato Si'. He speaks of a technocratic paradigm. It's not a rejection of technology, it's a rejection of a certain kind of technology, which can only think in one way, which is the world is an object we can manipulate for our good. We don't see the connections, we don't see the communities there. And we think in a one-dimensional way. We say, what's the technical solution for this problem? Rather than asking the broader moral and civilizational questions about what are we doing to our world? Okay. My response to the answer of how I use science. Knowing that carbon dioxide and other greenhouse gases control the Earth's thermostat, and based on historical data of how temperature has increased in tandem with carbon emissions, we can project future temperatures based on further emissions and calculate what is called a carbon budget. How much we can emit total. If we wish to keep the total increase below 1.5 degrees Celsius, the Intergovernmental Panel on Climate Change in 2018, consulting hundreds of studies, calculated that we can release an additional 570 gigatons of CO2 and have a 66% probability of staying below 1.5 degrees Celsius. If we're willing to play more dangerous odds, 50-50, we can release 770 gigatons. The uncertainty here is give or take 400 gigatons. Global CO2 emissions currently amount to around 42 gigatons a year. That leaves between 9 and 15 years of emissions at the current rate before we have to make a hard stop to stay below 1.5. We have no time at all to begin to seriously transform our energy systems, and so that we can significantly taper down more gradually and hope to not overrun that target by a significant amount. Alas, the climate system has some surprises waiting for us. Dr. Moss is right, there is no one tipping point. There are many, many tipping points that scientists are investigating and are well aware of. I'll list a few. The reflective loss of Arctic ice. The ice caps are a major part of the radiation balance of the Earth. From space, their brightness is visible. That's sunlight bouncing off them. You can see that from the moon. You can probably see that from Mars if you have a good enough telescope. That's radiation that isn't absorbed by the planet. As the ice caps melt, that bright white light ice, which you need glacier glasses to walk on, becomes dark green Arctic water, which absorbs light, and especially absorbs infrared light, absorbs heat. Polar ice on both hemispheres is diminishing, and with that, it's absorbing more heat. The Arctic ice cap is on track to melt entirely, leaving dark ocean water, which will absorb more heat from the sun. Scientists calculate that this will have the equivalent of 1,000 gigatons, about 25 years of current emissions. We'll certainly be at that state. We'll be absorbing that more heat, and we'll have to take that much more carbon dioxide out of the atmosphere to get back where we started, right? We'll be at a new state. Melting permafrost. The Arctic portions of the northern hemisphere are currently frozen. Enormous amounts of organic material are frozen in ice. Leaves, mammoth bones, moss, all sorts of things. As that melts, and it's melting right now, those things become warm, bubbling compost, and they emit CO2 and they emit methane, just like your backyard compost pile does. This is calculated to be somewhere between 1,400 and 1,800 gigatons CO2. Remember, our budget is between 570 and 770. That's the total. That's predicted to be emitted at about 1.1 to 2.2 gigatons per year over the next century, accelerating with temperature increases. Another major issue that's been another major source that's been an issue in previous climate changes, suboceanic methane in the form of clathrate ice. Hundreds or thousands of gigatons equivalent of methane are held there. As the water warms, that goes out of solution. The good news there, that's an endothermic reaction, so it doesn't feed itself. But you warm it enough that methane bubbles into the atmosphere. Methane levels are currently spiking, and we're trying to figure out why. They spiked quite a lot in the past 2 years. Is it human caused? Are we leaking gas? Or is that starting to happen? Our situation is dire but not impossible. We are currently running downhill towards a cliff. Every additional step moves us closer into danger. We have to find a way, we have to find the will and ways of cooperating to turn around and begin the hard climb back to a sustainable form of life. If carbon dioxide is part of the Earth's day-to-day thermostat, the broader cycle of carbon is part of how temperature is regulated over eons. Aquatic life and land plants die and build up layers of carbon, which gets buried through sedimentation and drawn under by subduction faults. This removes CO2 and carbon from the life sphere and lowers the average temperature of the Earth. Over millions of years, this gets compressed into coal or petroleum or natural gas through various complex processes. Fossil fuels, as we call them, are mostly the remains of the forests and primordial seas prior to enduring the Carboniferous period, 359 to 299 million years ago. There's an important lesson to this, as the geological evidence suggests that the average temperatures at the beginning of the Carboniferous period were about 10 degrees warmer than present. There are, of course, many complexities to the change of climate. CO2 is not the only one. But our burning of these fossilized forests puts that CO2 back into the atmosphere and bumps the thermostat back towards the higher setting of that time. That's what we're doing when we burn carbon fuels. We're putting the amount of carbon in the atmosphere that was once there before, often in much harder times. That is a climate that pushes humans beyond their biological limits. At our current level of global warming, heat waves are regularly happening with sustained temperatures above 100 degrees, and often above 110 and 115. When combined with high humidity, humans cannot survive at those temperatures. There are eras in the past on this planet where our biology doesn't work. That is one of the things we court when we're putting this fossil carbon back into the life cycle. Thank you.
Okay, there's so many technical errors with what was just. First, the Antarctic ice is not disappearing. It's actually greater than it was. Over the Arctic, the ice over land is continuing. It's only the ice over water that's melting. It is certainly not true. I've read the IPCC report. It is not true. The IPCC report calls some kind of tipping point or some kind of extreme condition will occur if we cross 1.5 degrees centigrade. It's simply not true. I think this is so terribly immoral, really, to say that there is this limit to warming, that we're going to cross in only a few years. We're already 1.2. We will be at 1.5 very soon. And to suggest that there's some major change that's going to happen in extreme weather or whatever is simply not there in the models. It is just not true. Let's talk about some of the impacts. Food production is up in the world. The number of people that are injured by extreme weather is actually dropping precipitously. And there was some criticism of this issue about weather forecasting, why that's extraneous. It's not. A lot of the discussion about climate change is about extreme weather. Well, nothing is more important for extreme weather than to be able to predict it ahead of time, because you can get people out of the way and you can save people. If a hurricane is approaching the coast, you can pull people away from the coast. So it is simply not true to think that weather forecasting is not crucially important for saving lives. It's already saving lives. So I just want to get back to the IPCC report. If you read this report carefully, it does not talk about dramatic, catastrophic changes happening at any single temperature range, 1.5 or 2.0 or whatever. There is no tipping point in the models. Now, it's true the ice will melt in the Arctic. You know, as we get later into the century, that is probably going to be true. The models have that. None of the models have any kind of tipping point that all of a sudden the Earth becomes unlivable. That is simply not true. And I should also mention is that as we warm up, and we will warm up, we're getting wealthier. We're able to protect ourselves. This is not a catastrophe. If it's getting warmer, you use air conditioning, right? Think of who would live in Phoenix or Las Vegas without air conditioning. We have the technologies to mitigate a lot of these problems. If there's less water, well, we can adjust by using crops that use less water. We don't waste it on so much hay, for instance, as an example. We switch crops. There's much that mankind can do. So global warming is, not great. We don't want the planet to necessarily warm up rapidly. But it's not going to warm up so much that we cannot keep our lifestyles or even improve them as the Earth warms up. So anyway, I think I'll stop there, and maybe we can talk more about science later.
For our second 10-minute subsection, Dr. Miller will speak for 3 minutes, be rebutted by Dr. Mass for 2 minutes. Dr. Mass will transition to 3-minute. Dr. Miller, the 2-minute to close us out. This topic is morality. Morality. This question will ask the participants to explain how their position on this issue intersects with what can be termed morality, or quote, moral considerations. Aware of the immense flexibility, even vagueness of this term, participants are invited to define and frame this as they see fit. Having done so, please explain what the quote, moral implications of your view are upon humanity, if any. Dr. Miller.
Just to be clear, once again, I'm not saying that there is a tipping point. I'm saying there are many tipping points out there that will engage at certain temperature ranges. And there's been recent research trying to spell out the importance of very many of them. I only listed 4 or 5. There are scientists who are studying 9 to 12 major tipping points that will fundamentally change climate in ways that hurt particular populations in particular areas, and also will make dialing back global warming much more difficult. So it's not a question of one, there are many. And this science is out there and you can find it. Morality. I'd like to return to Genesis and think more about the role that humans are given in Eden. The Lord God placed Adam, his name itself is a play on the word for soil, Adama, in the Garden of Eden to cultivate and care for it. Or, as the King James translation has it, to dress and to keep. The Hebrew words are interesting and very complex, and these go in tandem with Genesis 1. This is Genesis 2. The first, avad, work, normally means to work for someone, as a servant or a slave. It also has religious meanings, serving a deity, Yahweh, or other gods. When referring to a material object in the Bible, notably, it is, with one exception, always used for soil. Care for the earth. To dress and to keep. Keep. The second word is shamer. Care for. Such as shepherds keeping flocks, which is in turn used as a metaphor for God and Israel and for Christ and the church. It is also used in a religious sense. Keep the commandments. Keep the Sabbath. Humans' role in the dominion of the first chapter of Genesis is reverent religious care for the rest of creation. It is not absolute mastery without any limits. It's to serve creation. This is very clear. These texts go together. You can't have Genesis 1 without Genesis 2. You can't claim that dominion without reading the rest of the story. We are to dress and to keep, avad and shemer. As I said before, this challenges us on two levels: sin and our limited ways of perceiving and judging. It challenges our sinful focus on ourselves, our tendency to imagine ourselves as separate from the rest of God's creation. Our technology will save us while the rest of the world burns, dries out, turns to desert, the ocean's empty, but we'll be okay. History in the present moment show that there is no shortage of such violent, excessive consuming, taking, and theft. But it also challenges us to develop our attention, to learn how natural systems that support life work, and to allow that knowledge to guide our actions. This challenges our default models of moral, space, and time. These are in the background of how we imagine morality. We've developed our morality for village life. We know if we steal from something, or we hurt someone's home, or we hurt their children, that we are creating something, we're doing something immoral. But we act now over long distances and large times, and we don't really know how to judge those acts. An ordinary person might consume goods that come from dozens, if not hundreds of places in a day. And we have little time to give thought to what those actions are doing. Our coffee, our orange juice, our underwear, our hamburger, where do they come from, what have they done? We can't really track that down, so it just becomes amoral. Every one of them is an act, doing something around the world. We enjoy the things that burning fossil fuels brings us, but give little thought to its impact. Every pound of CO2 that we emit impacts the entire planet, and even more challenging for our moral imaginations, it impacts countless generations that will follow us on the diminished planet we're leaving them, our children and our grandchildren. I want to end by talking about climate debt and responsibility. Dr. Moss keeps saying that technology and the economy will keep growing and things will be fine for us. They will not be fine for the entire world. This will polarize the world, increase inequality. Right now, many of the most severe climate impacts are being felt by people in nations that have contributed little to global warming. Flooded island nations in the Pacific, drought and severe rains in Africa, catastrophic flooding just this year in Bangladesh and Pakistan. Pakistan has suffered perhaps the most severe climate disaster we have seen. We haven't paid much attention. 33 million people are homeless. 70% of their crops are gone. How are they going to eat? Pakistan has contributed less than 1% of historical CO2 emissions. High contributing nations have a special moral responsibility to those who are paying the price now. Now, not in the future, not after some hypothetical tipping point that doesn't exist. Right now, people are suffering. The US is responsible for 25% of total historical emissions. Europe is responsible for 22%. China, the current lead emitter, is responsible for only 12% historically. We need to develop a moral imagination that can see what we owe to the people of Pakistan and others like them. Thank you.
Okay, let's talk about morality. Let's talk about morality today. Hyping and exaggerating the threat of global warming, we just heard a little bit of it just now, is not ethical. It hurts the most vulnerable among us, making certain people very anxious and fearful. We even have classes in the University of Washington, people who are afraid. This kind of exaggeration stokes partisan anger and suspicion. And let's talk about poor nations. It is immoral to deny poorer nations the energy resources that we use to build a modern society where people can live fulfilling lives. We cannot deny the poorer nations of the world the ability to use energy that we use to live the kind of lifestyle we live. It is immoral to push for restrictions in energy use and increase the prices that hurts low-income people in this nation and other nations. It is immoral for politicians and activists of any viewpoint, right or left, to distort the science for their own political advantage. And it's unethical for the media and others to lie and distort about global warming to get folks to do the right thing. Just to give you an idea of the damage of this kind of exaggeration, there's a class at the University of Washington, Bothell, on climate grief. There's books on climate grief. I get calls from people afraid about what climate change is going to do to them. And I would say it's really unethical to do so. So remember, using fossil fuels is not for us alone. China brought its living conditions up hugely by using fossil fuels. India wants to do this now. Africa next. These nations want to use fossil fuels like we've used fossil fuels to live more fulfilling, safe, and healthy lives. And it is immoral to deny them the right to do so. It's just not about us. It's about their use of fossil fuels as well. Thank you.
What do I talk about?
On morale, here lets you
What do I just did morale.
continue on as long as the 3 minutes of yours.
Okay, I talked a little about morality I want to talk about. Okay, I'm done with morality. Anybody wants to talk about morality?
2 minutes to
Okay, I'll say one thing. There's a lot of facts being thrown around here that are just not true. For instance, we just heard a discussion that island nations are going to be flooded by global warming. This is not true. Every study, and this is in the IPCC too, talks about how the islands in the Pacific, the people who are worried about flooding from global warming, they're not flooding, they're actually rising. They actually rise as the water levels rise. So there's just a lot of this hype and exaggeration, wrong facts. And this thing about having molting tipping points, I never heard that one before. When we talk about tipping points, we're talking about the climate of the planet, whether it's going to start going into uncontrolled warming. When you use the word tipping point, that's what you're referring to. This idea of multiple tipping points, I haven't heard this one, okay? There's one climate system, and that's the one that we're worried about, a tipping point, and that's what the climate models don't indicate.
Let me talk about those tipping points again because they're widely studied. I'm very surprised that you don't know about them. It's not some secret paranoid thing. I'll list the tipping points again. The loss of Arctic sea ice. You can go on the NASA site, Charctic, and you can watch the gradual melting of more and more ice over water. It is, as I said from the beginning, the ice over water that matters. That dark water will absorb heat that's currently being reflected. You can find projections for what sort of equivalent of CO2 that will bring. Another tipping point is the collapse of the Amazon rainforest system. It will shift at a certain point of heat and dryness into grassland and savanna. And it will cease to be a tropical rainforest that currently has its own hydrological cycle and keeps itself going. If you cut too much of it away, the rain begins to fail, and the heating around it will accelerate that. That is widely known. The current that turns over the Arctic water and the Caribbean water and the Atlantic is widely watched, and it's been studied for years. And the question is, when will that current shut off? That won't warm the planet, it will actually chill down the eastern seaboard and much of Europe, but it will have profound impacts on food production for the United States and for Europe. Other tipping points include the Greenland ice cap, when that's irretrievably gone. I could go on and list more and more. There's a recent article out, I don't have the quotation here, it is by Major Climate Science, trying to establish the thresholds for those tipping points and finding that many of them are already engaged in 1.5, just beginning to be, and trying to put some specific limits on where they will kick in after that. We need to know what those numbers are. That is serious science, And those numbers matter profoundly for our future. There's not one tipping point. There's 9, there's 12. On morality, one rebuttal, poor nations. It's wrong to deprive them of the fossil fuels they need to develop like we had. This is a fundamental problem. If India and Africa develop their economies with coal the way we did, there's no way we stay under 2 degrees. We blow through that. That's bad for them, that's bad for us. The Paris Climate Agreement attempted to address this. This is a policy proposal that the world agreed to. It's the Green Climate Fund. First world countries that have already developed their economy using those historical fossil fuels will pay countries that have not yet developed their economies to develop more sustainable forms of energy, to leapfrog over all the coal power plants that China used to get where it is, that we use to get where we are. The world can't afford that. So it's our obligation to help them get the technological advances they need to move past that. The Green Climate Fund is something I support. It's perhaps not the fullest answer to that question, but it's a serious policy proposal that takes that problem and tries to solve it. It is not simply ignoring the concerns of poor nations. Let's turn to economics. How much will this cost? There are 2 different sets of costs we need to consider: the cost of transforming our energy systems and the cost that climate change imposes upon us. Let's start with how much addressing this problem will cost. In 2014, the IPCC calculated it would take between 1.7 and 4.8% of global GDP from 2030 to 2100 to keep the temperature rise below 2 degrees Celsius. That is a lot of money. But it's not just a loss, it's economic activity. It's jobs, right? It's building a new energy system. The IPCC has avoided giving hard estimates for the cost that climate change will bring. There are some small estimates, but they don't put a lot of weight in them because they say it's far too complex to calculate what those costs are. A group of economists, well, let's list the economic impacts of climate change. They're profound and growing. So-called natural disasters are increasing as what were once 100-year storms happen more regularly. Yes, it's true, the number of hurricanes is not changing, but as the Caribbean and the Atlantic warm up, the severity of those storms is increasing. And Category 4 storms become much more likely as the water warms, and Category 5 storms are almost impossible without extremely warm water. And there's a direct relationship there. The 40-year annual rate of natural disasters in the United States, costing $1 billion or more, adjusted for inflation, is 7.4 per year. In 2019, we had 14. In 2020, 22. In 2021, 20. We're a little bit behind this year. As of Hurricane Ian in October, we had 15. That's still twice the 40-year average. These could be ignored as other people's problems, but the increase in fires, hurricanes, and floods threatens the public and private insurance systems and reinsurance systems that undergird much of our economy. We don't know about these companies, but we depend upon them. Consider the range of broader economic impacts. We've talked about agricultural production. One widely cited study projects a 10% global reduction in agricultural output per degree temperature increase. Think about what that will mean with a 2, 3, or 4 degree increase. Current measures show that agricultural productivity per acre has been declining for the past decade. But we're bringing more area into production, so that's being hidden. But I mentioned in my first talk about the worldwide crisis in grain crops that has been happening in the past year. Rising CO2 levels are acidifying the oceans, making the base level, the plankton that's at the base of the food system of the ocean, making it hard for those animals to live. They're small calcium-shelled creatures that provide the krill that other things eat and goes up the food chain. And with more and more acidic ocean water, half the CO2 is going into the ocean, making it into carbonic acid, it's becoming harder and harder for those creatures to form their shells. This is widely known, widely studied. There's fossil evidence that that's happening in past periods of climate change. Agricultural workers are already dying during extreme heat events. Sea level rise will destroy this is much longer term. Sea level rise will destroy the homes and cities where 10% of the world's population lives. This is over a century. That's untold trillions in losses, but just stay with the economic impacts for a second. That would result in the loss of all the world's deep water ports, right? So at that point, we're not going to innovate ourselves out of that. To rebuild Long Beach, to rebuild Newport News is not something that you just do on a weekend. Those are major investments in infrastructure that have been built over nearly a century. All of those will be flooded. Numerous groups of economists have attempted to calculate the future cost of climate change. In 2015, a group of Stanford economists calculated that unmitigated global warming would most likely result in a 23% loss of global GDP by 2100, with a long tail possibility of greater than 50%. Unlike the cost to address climate change, those are almost pure losses. Now there is economic activity in there as disaster relief people do, and firefighters are engaging in these things, so there is actual work in there. But a lot of that's just pure loss. So compare those looming costs with the very expensive cost of 4.8% of GDP, and you see that it is something of a bargain. We should also discuss how much money governments are currently subsidizing fossil fuels. The US is part of a G20 working group on fossil fuel subsidies. In 2021, it reported $8.2 billion in tax subsidies to coal, oil, and gas. That's just federal, not state. There are many more. By comparison, the recently passed Inflation Reduction Act included $3 billion a year for 10 years in subsidies for sustainable energy. An International Monetary Fund report attempted to account not only for production and consumption subsidies, but also what they call implicit subsidies. I just call them market externalities, most economists do. The full cost that burning carbon fuel brings in environmental destruction and lost tax revenues that results. For that, the International Monetary Fund, not a left-wing organization by any stretch of the imagination, calculates that those global costs for 2021 were 5.9 trillion. This is what's called a market failure, an externality, a cost that's part of production, it's a cost of part of what we enjoy, that's not processed by the market. Imagine two companies that make the same thing, and there's a toxic result from what they make. One company is free to dump it into a pond behind an elementary school, the other company is in a place where they have to pay the full cost of disposing of it responsibly. Which company is going to be able to sell it for cheaper, right? The one that can dump it irresponsibly. That's an externality. That cost is being borne by someone else. I get the thing, the elementary school pays the cost, right? That's an externality. The market's not functioning. What we have with carbon fuels are definite future, current and future costs that are not being processed by the market. That's a market failure, and there are recognized ways of addressing that we can continue to discuss. Thank you.
Okay, I guess we're talking about economics now? Is that what I'm doing here? Okay. Well, let me just talk about, we're talking about, you heard a little bit about, fossil fuels is used to generate a lot of electricity, but there's a lot of things that fossil fuels are needed for that can't be replaced by renewables or really any technology we have right now. For instance, fossil fuels are used for fertilizer, to create fertilizer. Extraordinarily important to keep the agricultural production of the world up. In fact, recently, some environmentalists pushed the leadership in Sri Lanka to stop using fossil fuel-based fertilizers, and the agricultural productivity collapsed. People were hungry. The government was destabilized. There are many other things that only fossil fuels can be used for that we need. Concrete is a good example. And how about shipping across the oceans? I mean, there's no renewables that can drive these gigantic ships that move things across the ocean, or aircraft. So, I mean, there's a deep literature on this that maybe, maybe 15% of our energy use is in terms of electricity that can be easily be replaced with renewables. But much of what we need in terms of energy can only come from fossil fuels. And at this point, we do not have options to replace it. Now, let's get back to this thing about the damage due to global warming. I mean, I think what we've heard is extraordinarily exaggerated. Even in the worst case, assuming that we keep on burning fossil fuels crazy like we're doing in the past, the IPCC, in their report on the economics of it, the US climate assessment, and the work of Nobel laureate William Nordhaus, found that global warming only cuts growth by a few percent. Growth. We are not talking about any major economic damage to the world. We will be much richer even if we don't stop the warming. There is no existential threat. Now, many of the impacts of a modestly warming world can be dealt with a modest investment in adaptation. And I should also note to you there are economic winners and losers in global warming. Some nations will move forward, like places in colder climates. And one thing you don't hear about is cold kills more people today than heat. And so a warming world is not necessarily a world where more people die. Think about there. There are some potent economic tools that are available. Some of them we haven't used, like a revenue-neutral carbon tax. We tried to do that in the state of Washington, and in fact, the environmental community unfortunately came out against it and stopped it. But there are bipartisan solutions like carbon tax, which brings the money back to people of lower income that actually could be very useful tools. Well, let me go back to some of these other things that we just heard. And some of the things you heard are just not true. I mean, facts matter. There is not an increase in 100-year storms. That's not happening. I don't know what 100-year storms are being talked about here, but we are not seeing that. Here in the Northwest, our big storms are big cyclones coming off the Pacific. They're not. 100-year storms are not increasing. It's simply not true. In terms of hurricanes, there is no increase in hurricanes hitting the United States. It is simply not true. Now, as the planet warms up by the end of the century, we may in fact see more Category 4 and 5 hurricanes. But that's not yet. That's later in the century. We have not seen this happen. Now let's get back to the tipping points. We heard about, there's not one tipping point, there's multiple tipping points. And I think this is a terminology difference we may have over here. You're talking about some local feedbacks. I mean, one of them is in the sea ice melting in the Arctic. You talked about Brazil. I'm talking about global tipping points. You can have various local changes, but what really counts is the total energy balance of the planet. The question is, are we going to have some kind of major tipping point? And some of the tipping points you mentioned are just not happening, and in the current models suggest they won't happen, like the failure of the circulation between the Arctic and the equator, this deep circulation in the Atlantic Ocean. The latest science suggests that will not fail. So we got to be careful about this. If you look at the best science, there is no end of the world coming. I mean, I work with these models. I look at these models. They do not predict this end of the world. And this artificial threshold of 1.5 or 2 makes absolutely no sense. There is no science, there's nothing to support that these thresholds are important. And when these are being used as a tool to get people worried, to be panicked, we have to stay below this threshold or the end of the world's going to happen. But there's really no facts behind it. And I'd like you to show any scientific evidence from IPCC or any other scientific document that suggests something is significant about 1.5 or any other threshold. It's simply not true.
I've tried to cite the studies that I'm using. On 1.5, yeah, no, there is no hard wall where everything ends. As I said, my image is we're running down a hill towards a cliff. We need to stop running down that hill. Every step gets worse. We're not dead. Extinction doesn't happen with the next step. But there is a point where we run too far. What scientific study says that 1.5 is a threshold we shouldn't cross? The 2018 report by the Intergovernmental Panel on Climate Change about global warming at 1.5 degrees. It was issued after the Paris Climate Agreement, which tried to embrace a 1.5 degree target, which is enormously difficult, and perhaps not quite possible to meet at this point. And so there was a lot of wavering in the policy communities around the world, saying, well, maybe 2.0 is not too bad. And they said, we will show you the difference between 1.5 and 2.0. A very large document published by IPCC.ch. Go there now, go there tonight, you can read the whole thing. They'll tell you the difference between 1.5 and 2.0. No, it's not a brick wall where everyone dies and everything falls apart, but enormous suffering comes between 1.5 and 2.0 that we could avoid, and we should try to avoid. It's not simply increment. Every little bit farther we go, more damage happens to people around the world. The Haber-Bosch process does use fossil fuels to make ammonia. It's a fundamental part of modern agriculture. And the traditional Haber-Bosch process, as it's currently being used, emits about 1% of global CO2 emissions. It's a big target. There are ways people are working on various catalysts and revised ways of making ammonia from methane that is less CO2 emission intensive. So there's a possibility there. It's not simply yes or no, right? If you're worried about climate change, you're an extremist and you're going to get rid of all global fertilizer. I don't know what people did in various countries, but there are scientists working on changing that process, coming up with a less climate damaging version of it. This is well known. The science is being done. Engineers are devoting their lives to it for good reason.
Thank you. Thank you very much, gentlemen. I think you'll agree with me, this debate began 10 minutes separate, and it's being more and more musically compressed through these 3-2, 3-2, 3-2, almost begging for a presidential debate style live open debate. That, in fact, is our penultimate section, live debate. It'll be 2 questions, 10 minutes each, but the time here is a little bit tricky. One presenter will speak uninterrupted for 90 seconds, a minute and a half. His opponent will respond for 90 seconds, but then 7 minutes, the remaining 7 minutes of each question, will be free-for-all, open debate, exchange in live time, in real time. This first question, the topic is political solutions/ideas. This question will ask the participants to explain their views on the role government or public policy or politics, broadly construed as they define it, can or should not play in the climate change debate. The participants will, as I mentioned, follow a 90-second opening live debate over 7 minutes, at which point, when the time runs out, I will return to the podium to pose the next question. For this first question, Dr. Miller will go first for 90 seconds, Dr. Mast 90 seconds, then gentlemen, 7 minutes of live debate.
The politics of climate change are both enormously demanding and somewhat simple. The technology we need to transition away from carbon exists. Prices for solar, electric, wind, and batteries have fallen rapidly over the past decade, now on par with costs for oil, and probably with the recent raises in natural gas on par with that. Coals, we have a bit of way to go. Policy question is how to make the change on national and global scales. There is a range of effective policy moves that are available, suited to any political philosophy you may have. Are you suspicious of government and prefer free market? Well, then you can focus on ending those subsidies that I talked about in my last presentation. The U.S. is currently paying $8.2 billion to subsidize carbon industries, right, which are making record profits right now. And record profits for a long history, right? They're making record profits. We do not have to subsidize them anymore. Take that away. If you are a libertarian, just take that away and let the market work and let those other energy systems have their way. Globally, that's $634 billion. The global percentage of subsidies is 70% for carbon fuels, 20% for renewables, 10% for nuclear and other. Right, so you could just wipe that out, then you'd probably be in a better situation. So if you're a free market, anti-government person, you can pursue that. You can go to zero, or if you're a slightly more engaged, democratic, liberal or democratic socialist kind of person in the middle, Europe and what the United States can sometimes be, you could take those subsidies for carbon and put them towards renewables. Or you can go full authoritarian. There's a whole range of things you can do. We have many options.
Okay. Well, nothing in life is simple. And I think we need a pragmatic, bipartisan approach to dealing with this problem. Clearly, we have to invest in new technologies. We'll probably be agreeing on that. Fusion power, I think, is closer than you think. Battery and storage technologies. We need to work on the nation's infrastructure, like better transmission lines. We need to put a lot of effort into adaptation. We haven't heard enough about that tonight. Adaptation to the climate that we have now and adaptation to the future climate. And a good example of that, of adaptation, is fixing our forests. We have ruined our forests. They burn catastrophically. We need to fix them. And just to give money to my folks, we need more money for global warming physics and research. So I'm very, very hopeful that new technology like fission, new fission, modular fission and fusion is going to provide a lot of the energy we need. So science is important, technological development is important, and I think we can do this in a bipartisan way, but nothing in life is simple.
I hope fusion comes tomorrow. It's been coming my entire life, and I hope I live to see it. That would be wonderful. That would be nice to be saved by that. But if technology doesn't save us, perhaps we can change the way we act in the world on these grand levels. The biggest political obstacle we face to changing our energy system is stranded assets. I talked about that carbon budget before, 570 gigatons left that we can burn before we blow through 1.5 on our way to 2.0. There is approximately 1,000 gigatons of claimed reserves that fossil companies are planning on selling, right? This is part of their stock price. And it's one of the largest sources of climate obstructionism, right? That's $5 trillion worth of assets that will become worthless if we have an effective policy that moves us away from carbon to sustainable energy. We have to solve that problem. It's an enormously difficult problem. The one solution I've heard proposed is by Dalton Chen, a carbon coin proposal, that you would create a global reserve currency, a new one, that's based on not burning carbon. And if you could prove that you were not burning carbon, or removing carbon, or engaging in agriculture that did not release carbon, or captured carbon, you could get some of that reserve currency. That is a brilliant idea that's fiendishly difficult to imagine how you would enact it. But that is the elephant in the room. $5 trillion in stranded assets by very powerful people who can engage in denial. Denial's out of style now. So now we do greenwashing. We say that we're going to be carbon neutral by this date. Or we do strategic delay. We say, well, technology will improve. Answers are coming. Let's not be hasty. Let's take this. Let's be moderate about this. We need to deal with those $5 trillion in stranded assets.
I don't think we're going to solve this problem by blaming oil companies. Now, that's been tried now for 10 or 20 years, and it doesn't work. We're not going to fix this problem by making people feel guilty or some kind of social change. The only way we're going to fix this is technologically. I mean, if it was so easy to do, if we had the technology to do it now, we would have done it, and we have not done it. And it's not because of some greedy oil companies that things are not happening. We need the science and technology to do two things: to provide the energy we need, to take carbon dioxide out of the atmosphere, and finally to adapt to the changes that are inevitable. They're modest, but they're inevitable. That is the solution forward. Blaming oil companies or about stranded assets, that goes nowhere.
Stranded assets is not blaming oil companies. It's a historical problem. We have $5 trillion in value that has to be taken off the books in order to transform our energy system, right? That is just a problem. It's not because they're bad people. I own a lot of that, I'm sure, in my retirement accounts. I don't know what's in all those funds, right? I try to invest in renewable energy in some targeted ways, but the bigger things, I'm not sure what's going on.
But that's not the problem. The problem is we don't have the technologies yet to replace fossil fuels. And until we have those technologies, and until we get the adaptation down, you know, we have issues that we have to worry about.
We have the technology right now to begin to make the massive transformation that we need in order to become carbon neutral by 2050. We do not have all of them right now, but photovoltaic systems are fully mature technology.
But they can only take, photovoltaic systems are nice, but electricity is still only about 15–20% of our energy use. There's the rest of it that we have to deal with.
Yes,
I mean,
that's why they don't.
we can do things on the side that are helpful, but we cannot solve the problem certainly not by 2050, without some major technological advances. And fusion, I think, is the big hope. And you know, you were saying that fusion may not show up so soon. Recently, I went to a lecture from 3 major fusion companies here in the Northwest. They were laughing about it, but people always say it's 30 years away. They said we're 5 to 10 years out. They think they'll happen. And so once we have fusion, then we are in a much, much better position. But until fusion shows up, we can use fission. Fission power is something the environmental community has not taken advantage of. In fact, it's actually worked against. And it's time, and we have to work hard to use nuclear to replace as much fossil fuel as we can at this point.
There are plenty of environmental activists that embrace nuclear fission as a part of the solution. Yeah, I hope that we're saved by fusion. I hope that comes very soon. I hope we're saved. I hope there's a technological answer that solves everything. We can't wait for that, though. We need to start now.
Well,
Yes.
why can't we wait? What can't we wait for?
We have technologies right now that we can begin to substitute in our energy system to begin to draw down our carbon emissions. Your
But we're
point-
doing that already, aren't we? I mean,
we're not.
we're massively putting in windmills. When I came over here from Seattle, I saw a whole slew of them. And photovoltaics are going, we're already trying these technologies.
We're trying them. The question is, are we adopting them at scale, at adequate scale and speed, right? Or are we putting obstacles in the way of them? In my state of Ohio, we had sustainable energy requirements for any power provider. And a major lobbying group came in and gave us sample legislation that ended that. And we now have no sustainable energy requirements for our energy, right? So what I buy from the tap. Not only that, they subsidized a end-of-life nuclear plant through our utility bills. And while they were at it, they threw in an end-of-life coal plant in Indiana. So when I pay my power bill in Ohio right now, I'm subsidizing those end-of-life technologies. So they made it much harder, and they made feed-in tariffs much harder in my state. So yes, we have the technology. We need to have the policies in place to make them be able to enact at speed. The point about only 15–20% of our energy is electricity, another big part of going forward is to electrify as much of the economy as we can, right? That's what electrifying cars is about. There's a much greater efficiency for an electrical engine than an internal combustion engine, and it takes petroleum off the table, and it lets you tap into these other resources. Even if you're burning coal to do that, you're still saving carbon because it's much more efficient.
But that's not true. You don't burn coal to fuel electric cars. That is not a good deal.
Oh, it's not ideal by any
No.
stretch of the imagination, but the efficiency gain you get with an electrical motor versus the very inefficient internal combustion motor, you still come out ahead. I'm not proposing it as the way forward, but electrification does those kinds of gains that you can even use with your existing system and use less energy.
Gentlemen, time has expired
Okay.
for this question. Ask you to remain at the podium. We're to the last question of the debate, and it really can be it's about feasibility, implementation, effect. Basically, I would ask, speaking for the audience perhaps too, okay, take us into that future. What does it look like? Everything you've talked about with your views on climate change, how does this play out in the future? Why should we be reassured or motivated to act in accordance with what you have laid out for us tonight? The first 90 seconds go to Dr. Maz.
Okay, feasibility. Well, the fortunate thing is we have time. Global warming is a slow, steady problem. It's not an overwhelming problem. It's not one that's going to take us down in any time in the future. We have the technology to slow the use of fossil fuels, such as nuclear energy and renewables, and we need to bring these in, okay? So we should bring in the technologies we can. We also have the technology for substantial adaptation to the changing climate. We could work on thinning and bringing back fire to the Northwest forest. We could do that. And if there's worry about water, lack of snowpack, we can add more reservoirs. We have feasible implementation plans that can help us deal with global warming. So we have a lot more time than some are suggesting. So this kind of chaotic, panic-ridden decision-making that we have, we gotta do this before it's 1.5 degrees. This is highly counterproductive. We need a long view on technologies and adaptation, and we need to start working on it, and I think we're going to be okay.
It's not all or nothing, right? It gets worse with every ton of CO2 that's emitted, and we need to begin ending that as soon as possible, right? Stop running down the hill, maybe just skip down the hill, maybe walk down the hill, and then eventually stop. So I'm not saying that there's a crisis. We have to solve everything tomorrow, because we can't. But we do have to begin making radical changes in the energy system now. Right? We can't wait till we're at 1.5. It's not a question of then we start, right? I told you, we have 9 to 10 years of current emissions until there's no room left in the carbon budget. So if we start now, we can stretch that out for 40 or 50 years. If we wait till then, we can do it in 6 months, and that will not happen. If we'd begun 10 years ago, we could have stretched it out even more. If we'd begun in the 80s when these conversations started, it would have been a relatively easy transition, a demanding one, but not the kind of enormous heavy lift we currently face. The good news is that the cost of solar, wind, and batteries has been dropping, according to a recent study from Oxford University, empirically grounded technical forecasts in the energy transition 2021, I'm quoting specific people, and they chart that these solar, wind, and batteries have been declining at rates of approximately 10% a year. Solar since the 60s, we have numbers on that. Wind and batteries we've been tracing since the 80s, right? So these are downward trends. Fossil fuels with major fluctuations like we're going through right now have remained inflation adjusted relatively in the same range over time. Those are mature technologies. Those are resources that we're getting to the end of the easy stuff to get. Those aren't going to get cheaper. The other ones are. So this new fact has led climate scientists to revise downward the doomsday scenarios, the truly doomsday scenarios with, say, like 8 degrees Celsius warming, which was a possibility just 10 years ago, and now they're saying that because of these changes, even without major policy shifts, we're going to come in probably around 3.5. 3.5 is still far too high, but we're out of the absolutely catastrophic scenarios, and that's very good news.
Can I say something? Your numbers are wrong. Climate scientists didn't change from 8 degrees centigrade, or 8 degrees centigrade, to 2 to 3 because of what we're doing on the ground, because mankind is being better or anything. That's not, the science has gotten better. The science, and I work on this science, has found that the sensitivities were less than we would thought. We also found that some of the early studies used this crazy increase of CO2 and methane of the gas in the atmosphere that were unrealistic, and now it's clear they're unrealistic. We are succeeding. The fact that we're not, the growth has slowed because we're using renewables more, that's a success story. We are making progress. And there is no cliff ahead. You're talking about skipping till we get to a cliff. That cliff does not exist. That is what we found.
There is no temperature of global warming that will cause catastrophic.
There is no climate model simulation that's reasonable, that's following the path we're on, or even worse than we're on, that produces a cliff that we jump off, and all of a sudden there's this massive warming. No, it does not exist. It's not in the science. It's not in the IPCC report. Can you quote any section IPCC report that says that? It's not in there. I've read the report.
No, I'm not arguing. Let me just go back to what you said earlier about how science has changed. There's two kinds of science we need to talk about here that the IPCC uses. It uses climate science to project climate sensitivity. What increases in CO2 will result in changes to average temperature, but also other climate effects, right? So that's your work. But then the IPCC has been developing very, very complex models of society and economies over the past 15 years. And they've been changing those models. Those models aren't simply about climate sensitivity, your work. They're about how we plan economies. Do we have high growth models? Do we have low growth models? Do we have high carbon models? Do we have high sustainable models? Do we have high urbanization? Do we have low urbanization? These are enormously complex models, right? And so part of the change has been with the drop in the cost of sustainable energy, that those models, those socioeconomic models that are added together with your work, are no longer predicting realistic pathways
That's not
to...
true, that is simply not true.
I'm sorry, that's how the IPCC
No,
works.
it's not.
That's
You can't-
strange that you don't know that.
It's simply not
Okay, I encourage you just to go to the
true.
IPCC.
I've read the report. Okay.
I encourage you to go to the IPCC, look at the climate change, the first report of each round, and look at the representative carbon pathways that they use, and the SPCCs, I don't know what that stands for, that's the revised version for the most recent report. Look what RPC and SPCC means, and you'll find out that it's a real thing. I encourage you to do so as well.
Right, no, well, I know it intimately.
Well, then you just
Let's talk about it.
RCP 8.5 or SSP 5, 8.5.
That was used for a lot of the original studies. Well, it turned out that it was ridiculous. It was making assumptions that the United States and other nations would increasingly burn coal. There'd be no renewables. Population would go crazy. Well, those were completely unrealistic. Now, for the latest IPCC report, they start switching to RCP 4.5 and doing the model run.
They're no longer using RPCs.
They are SSPs. They're the same thing.
Well, it's a
Okay,
different system.
It's the same. It's the same thing. And the SSP is one where we have a moderate increase and then we get control. That is what they're using right now, and that's what I'm telling you, the most realistic climate simulations. And in those simulations, there is no catastrophic end to society. There is no tipping point. There is no cliff you fall.
I think you keep mistaking climate sensitivity projections with these socioeconomic
No,
projections.
I'm not. No.
These models are about choices we make in the future.
I know, but
right?
we
These are-
use those to drive the climate models. That's the way it works.
Yeah.
And so if you drive it with a more realistic future of greenhouse gases, the climate sensitivities show that we are not approaching the cliff. It's just not true.
So again, you seem to be confusing those two levels. I agree that science
I'm
is
not
constantly
confusing anything.
refining its understanding of climate sensitivity. That is your work, right? But the IPCC, the RPCs and the SPCCs are about political, economic decisions we make about how we go forward, about the policies we adopt. And those are different trajectories. Some of them are extreme and some of them are idealistic and they will never be achieved, right? There are different options so we can imagine what the consequences of our actions now are into the future. They're not about refining the understanding of climate sensitivity. They're about policy.
You're not understanding.
I guess we...
One, it talks about how greenhouse gases will change based on economic assumptions.
Yeah.
That's the SSPs, RCP, whatever you want to call it.
Yeah.
We use that in the climate models. I use that in the climate models
Agreed.
to drive these ensemble of these climate models.
Yeah.
Okay, we agree on that.
Yeah.
And all I'm saying is using a more realistic future, which everybody pretty much agrees on is more realistic, drops the climate sensitivity, drops the implications so far down that there is no tipping point that's going to take people off the cliff.
Yeah.
That's what I'm saying.
So I'll give you your tipping point doesn't exist thing.
Okay.
But yeah, part of those models, to get back to my original point, that I think you're disagreeing with, but I don't think makes sense. Part of those models is the changing price curves of sustainable energy, right? That goes into the models. That's part of what's changed. Yeah, and so those models are about policy decisions. They're not about crazy assumptions. They're about what if you pursued this
Oh, I
path?
understand that.
What if you pursued that path?
That is absolutely correct.
I'm glad we agree.
There are assumptions in those economic models.
Yeah.
Right. Right.
Well, it's very good to end this section on a point of agreement.
Good.
I'm very, very excited for the audience question section. Debate technically is over and your questions are coming next. However, before that, each speaker will have 5 minutes to make his case the final time uninterrupted. I ask both speakers to stick to the 5 minutes as they've done throughout the whole night. 5 minutes each, final case, and then It's your show. It's up to you to ask these two fine gentlemen whatever you would like to ask them. Dr. Mass will speak for 5 minutes, Dr. Miller 5 minutes, and then you. Thank you.
Well, I'm going to show you something that's kind of encouraging. In 1970, Cyclone Bola hit Bangladesh. It was a Category 4 cyclone. 300,000 to 500,000 people died when this storm hit. In 2019, a far stronger cyclone, Fani, hit the same area. 89 people died. What changed? Much better forecasts, much better preparation, evacuation. We now have the ability to forecast extreme weather, whether enhanced by global warming or not, and we have the ability to help protect people. So if the weather becomes more extreme, we have technologies to save people. So I'm going to end this with a very optimistic prediction. I'm very optimistic, quite frankly. I think this is a technical problem that we're going to solve technically. During the next few decades, we will master energy technologies to radically reduce our use of fossil fuels. I think we're going to get fusion power within the next 20 years. We're going to have better technologies for using energy. We will use our technologies for better adaptation. And another thing that we haven't talked about, that people are working on now, we will master the technologies of pulling CO2 out of the atmosphere. This is called sequestration. We're already working on this. All it takes is energy. If we have energy, we can pull CO2 out of the atmosphere, and if we have used fission power or fusion power, we can do that. I think the catastrophic predictions of some, that there's tipping points out there, or all these extreme things are going to happen, will prove unfounded. We don't see increases in most of these extremes. And adaptation efforts will make us better able to deal with current and future extreme weather events. So in the end, I'm very optimistic of what's going to happen, and I think we can get ourselves out of this, and I'll leave it at that.
Climate change, as I said, challenges our fundamental moral sensibilities about the space and time in which we act, what the nature of responsibility is. We need to expand our sense of moral space to the entire planet, which we are now able to influence. We need to attend to complex ecological and climatic connections. It's not simply about carbon emissions. We've been acting as if we were gods and the world was solely our object to exploit for most of civilization. We've cut down a vast swath of the Earth's forests. Less than 5% of the virgin forest in the United States still exists. Most of the grasslands in the United States no longer exist. Humans are only 1.01% of the Earth's biomass, but when it comes to mammals, we are now 36% of the mammal biomass on this planet. Domestic animals, our food, are another 60% of mammal biomass. Humans and their livestock constitute 96% of the Earth's mammalian biomass. This is, by the way, from the Proceedings of the National Academy of Science, Biomass Distribution on Earth study from 2018. I'm not making it up. We take more than is our fair share. We do not act as if we are members of a community of God's creation. We do not act like it's God's creation. We act like it is our object to exploit and use at will. I'd like to end by turning to Pope Francis's encyclical Laudato Si. The central idea in there is something called integral ecology. Integral ecology works on 3 levels. It's an understanding of reality. The creation reflects the relational nature of its triune creator. That as Catholics, we believe that God created the world, and the relational character of God is manifest in the nature of creation. Everything in creation is connected to each other. From this ontology, from this understanding of reality, there comes a way of seeing, right? That can be attentive to those connections, that can value those connections, that can be inquisitive about the nature of those connections. What is this thing? What's it connected to? How does it hold together? How does a forest work? How does a grassland work? How do the oceans work? How does the climate system work, right? To be attentive to all of those massive interconnections. And finally, integral ecology calls for valuing those connections, that we would hallow, respect, and try to restore the connections that we've so deeply wounded. Pope Francis speaks of a gaze of serene attentiveness, which we learn from Christ, to look at things with love and see their depths within them. The story of humankind since Genesis has been to ignore those connections. Cursed is the soil because of you. We don't care. We take what we want. This grassland will now be a plain solely for us. The rest of the animals can go somewhere else. And there's less and less somewhere else for them. 96% of the mammals on Earth are either us or our livestock. Again, the proceedings of the National Academy of Science. If we learn to look with love, with the gaze of Christ on the world, to heal that violent gaze of our original sin, we might find there not only responsibility, but the community. The community that Genesis warns we are always tempted to disdain. We find once again the flourishing together, the harmony of all creation that God saw was very good, and that was celebrated in the first Sabbath. Thank you.
I'd like at this moment to extend a deep gratitude to Father Chase, to the Vandal Catholic Club, to all of you and our two wonderful speakers for making this such a great night.